Okay, go ahead and throw your name on here. And it is currently first hour. Okay, a system of equations is still a collection of two or more equations. I made that blank way too small. And the solution to a system of equations is still the point that makes both of our equations true. Okay. I was telling you guys all week last week that last week we were solving graphically. Today we are solving algebraically. So today we are solving algebraically. We have all of the steps to solving a system by substitution written out here. Step 1 is to solve one of our equations for x or y. That is crossed out because in the problems we are doing today in substitution part 1, that step is already done for us. Alakai, grab a note sheet, please. Alakai. Alakai. There's your note sheet. Okay, so in step 1, or in substitution part 1, that step is already done for us. We already have one of our equations solved for x and y, or x or y. So step 2 is that we are going to substitute the equation that is solved for x or y into the other equation, and we are going to solve for our first variable. So substitution involves us taking one equation and plugging it into the other in order to be able to solve for one of our variables. And then we'll take the answer we got in steps 4 and 5. We're going to substitute that answer into the other equation, solve for our second variable, and then we'll know what both x and y equal, and we can write it as an ordered pair. So, this first system here, we've got y equals x plus 8, and 3x plus 3y equals 6. We are looking for the equation that is solved for either x or y. This first equation is solved for y. So it is solved, it is y equals x plus 8. So because we know y equals x plus 8, we are able to plug that in for the y in the other equation. So we're able to replace this y right here with an x plus 8. Because we know that y is x plus 8. So what that's going to look like is we are going to rewrite our entire bottom equation, but where that y is, we are going to plug in an x plus 8. Come get a note sheet, please. So we've got 3x plus 3, and then instead of y, we are going to plug in x plus 8 in parentheses, and that is equal to 6. Okay, any questions about that first step? Okay, one thing about substituting. Think about, I already told you guys I'm going to be gone on Friday. I'm going to have a substitute on Friday. When I get a substitute, do I still come to school? No. No. So when we substitute something in for y, the y disappears. We are replacing the y with an x plus 8. Okay, now, this was your quick, right? 3x plus 3 times x plus 8. We need to distribute, combine like terms, and solve for x. So we're going to distribute this 3. So we still have 3x here. 3 times x is 3x. 3 times 8 is 24. That is equal to 6. So that was distributing. Now we can combine like terms. 3x plus 3x equals 6x. Plus 24 equals 6. We can subtract 24 from both sides. We will get 6x equals 6 minus 24 is going to be negative 18. Running out of space. And then we divide both sides by 6. We're going to get x equals negative 3. So once we get things substituted, it's an equation just like we did back in Unit 1. Morning. Okay, we now know what x equals. We still do not know what y equals. So we are ready for steps 4 and 5, which is to substitute our solution we just got into the other equation. So we just used the 3x plus 3y equation. We're going to go use the other equation. So I'm going to just rewrite that equation over here. Y equals x plus 8. So I'm taking that equation. We now know what x equals. What does x equal? Negative 3. So x now equals negative 3. So we can take that negative 3. If you want to draw an arrow, you can. We can plug that in for x. So it's going to be y equals negative 3 plus 8. And then we just simplify that out. Negative 3 plus 8 is 5. So y equals 5. Okay, and then we're going to write our answer as an ordered pair. X always goes first in your ordered pair. Sometimes you solve for x first, sometimes you solve for x second, but make sure when you write your ordered pair, x always goes first. This is going to be negative 3, 5. Okay, any questions right now? Okay, we are ready to move on to our next one then. So, this first equation we did, we knew what y equaled at the beginning. This next one, we have an equation solved for x. So that's going to be slightly different. So, we still can skip over step 1 because we've already solved one equation for x or y. We are ready for step 2, which is to substitute that equation that is solved for x. So this is x equals 2y plus 5. This is important. We have to plug it in for x this time. So if you know what x equals, you plug it in for x. If you know what y equals, you plug it in for y. So since we know what x equals, we're going to plug it in for x. We can go ahead and do that. So we're plugging in 2y plus 5 for that x. So it's going to be 3, and then in parentheses, we're going to plug in 2y plus 5. And we've got minus 2y equals 19. Okay, 3 times that 2y is 6y. 3 times that 5 is 15. And I've still got minus 2y equals 19. That was me distributing. And now I can combine like terms. So I'm going to combine together that 6y minus 2y. 6 minus 2 is 4. They're on the same side, so I don't need to do opposite operations. So I've got 4y plus 15 equals 19. I can subtract 15 for both sides. 4y equals 19 minus 15 is 4. I can divide both sides by 4. I will get y equals 1. Okay. Any questions on solving for y? Okay, we are then ready to plug in that fact that we now know y equals 1. We're able to plug that in for x, or plug that in for y to solve for x. So I'm going to take my other equation, this x equals 2y plus 5, and that's the equation I'm going to use. I'm plugging in this 1, in fact I know that y equals 1 for this y right here. So this is going to be x equals 2 times 1 plus 5. Okay, 2 times 1 is just 2. So I've got 2 plus 5, and then 2 plus 5 is 7. So I get that x equals 7. We can write our answer as an ordered pair. Remember, x goes first, so 7 goes first, and then 1. Okay. Before we move on to the problems on the back, I do want to show you guys how you could check your answers to these if you needed to or wanted to. So finish getting that one written down and then look up for me, please. A few more people writing. All right, so we got an answer of 7, 1. So x is 7, y is 1. If we wanted to check our solution to this problem, we could plug in both x and y for x and y in both equations. So right here, 3x minus 2y, we would do 3 times 7 minus 2 times 1. So I'm plugging in 7 and 1 for x and y. Make sure I get 19. It has to be true for both equations. So then for our other equation, it's x equals. So that would be 7 equals, and then we would plug in 1 for y. So we do 2 times 1 plus 5. Make sure we get 7. 7 equals 7. So you could plug in both x and y into both of your equations and make sure that those check out, that it's true. Okay, any questions right now before we move on to the back? You can get it later. Be on time to class. Okay, flipping this over then. We have 2 more problems on the back, and you're probably like, oh my gosh, Miss Ho, these problems are so long. These 2 problems are 2 special cases of things that might happen. So we're going to start them the same way that we started those ones on the front, but something wonky is going to happen. So this first problem, do we have an equation that's solved for x or an equation that's solved for y? Solved for x. We know that x equals 3y plus 2. So we can take what x equals, that 3y plus 2, we can plug it into our other equation for x, because it is x equals. So you can replace things for things that they are equal to. So we're going to go ahead and do that. We're going to do 2 times 3y plus 2. And then we still have minus 6y equals 8. Two times 3y is 6y. 2 times 2 is 4. We got minus 6y equals 8. That was me distributing. The next thing I need to do is combine like terms. What's going to happen when I combine my like terms? They're going to cancel out. 6y minus 6y is no more y's. So my like terms are going to cancel out. I'm just going to be left with 4 equals 8. Okay. Think all the way back to unit 1. I think it was 1.6 or 1.7. If our variables cancel out and we are left with a false statement, how many answers do we have? None. So this is no solutions for this system. If you want to write note to yourself as to why, it's because our variables disappear or cancel, you can call it whatever you want. and you are left with a false statement. So if your variables disappear and you are left with a false statement, you are going to have no solutions. Last week, we graphed these. If I were to convert both of these to slope-intercept form, which would take a second, but I could do, and then graph both of them, they would be parallel lines, okay? So this is a different way of doing the same thing we were doing last week. It just doesn't make sense to graph this one because we don't know how to graph lines that are solved for x equals. Hey, last problem we have. We've got 2x minus y equals negative 8. We know that y equals 2x plus 8. So do we have an equation that is solved for x or an equation that's solved for y? Y. So we're going to take that 2x plus 8. Where can we plug it in? To this y right here. Okay. So I'm going to be plugging that in. It's going to be 2x minus, and then in parentheses, I'm plugging in the 2x plus 8. So this one's a little tricky because it's that minus y. We can put an imaginary 1 here, if that helps you. And that is equal to negative 8. Okay. We're going to distribute that negative 1. So we got 2x. Negative 1 times 2x is minus 2x. Negative 1 times 8 is negative 8. That is equal to negative 8. Once again, we go to combine like terms, and they cancel out. That 2x minus 2x cancels out. So those guys cancel, and we just have negative 8 equals negative 8. Negative 8 does equal negative 8, so this is a true statement, meaning we are going to end up having infinite solutions. So our variables disappear. And that is a true statement. And that is why it is infinite solutions. You can use an infinity sign or an INF. Okay. My biggest piece of advice to you guys today, because there are a lot of steps, but all of the individual steps are things you guys know how to do. You know how to solve equations. You know how to substitute things in. You know how to distribute. You know how to combine like terms. My advice for you today is to follow that list of steps that we put on the front of the note sheet. I'm going to stop this video.